All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to continue learning about ESP32 things. However, we have moved on to, or we are going to be moving on to async, um, async programming, async Rust for the ESP32. Sorry, I wasn't sure how to say that. We're going to be exploring async programming, but for the ESP32. I guess we can say async programming for embedded devices because I think async, I think the specific library, the specific framework that we're going to be exploring, which is Embassy, I believe it does also support. Yeah, it was written in the documentation that it does support other devices as well, like Pico, for example, and STM32, and a bunch of others as well. That being said, let's begin. I mean, oh, oh shit. We're having this gray screen glitch thing again. Before we begin, before we get into, the embassy stuff, I got this idea. I think it was yesterday or the day before, or I don't remember when, but I realized, oh shit, okay, we are dropping frames. Give me a second here. I'm just gonna do something to reduce the load on my network, and hopefully after that we should be able to continue. Yeah, I think we are good now. So, uh, yeah, dude, let's hope that we don't have too many network issues. I was having network issues even before starting the stream. They kind of smoothed out a little bit um, in the past 2 hours, let's say, and I was hoping it would remain smooth. But I guess when I'm streaming, then it does put a considerable amount of load on the network. Though, okay, it's not just the fact that I'm streaming. I'm streaming to Twitch from this machine, but um, a bunch of the things that you're seeing on screen, they are coming into this machine over the network through an RTMP feed. So there's that bit of load on the network as well. And then on another machine of mine, I usually have somebody's Twitch live stream running so that I have some sort of background sound. So that puts a certain amount of load on the network as well. I still don't know if it's an issue of my internet connection or if it's an issue of my router. So is it maybe my router getting old and needing to be replaced, or if it's something else? I don't know. Anyways, back to what I was saying. So in the past like couple of days, I've been realizing. Actually, I've been thinking about this for the past, I don't know, week maybe. I was like, okay, there's a bunch of stuff that I want to do with my content pipeline. I was planning on building a content pipeline. I'd set up a bunch of things for it. I can show it to you here. Let's go back one step, and I believe it was VOD splitter. Just so I would be able to remember. Um, why is there a log file for this? Okay, I'll look into that later. I think that might be from NeoVim. That means there might be some MD. Um, yeah, there's some MD01. That's why there's a yeah. Um, hold on. Give me just a second. Yeah, this is definitely a router issue, which I don't really know how to solve. I wonder if it would get solved if I did that thing that I haven't done for a very long time, which is switching off my router. Actually, that's not entirely true. I have done that recently. So there was this thing that I used to do a while back. where I would, when my connection would start misbehaving on certain machines, I would then, give me a second. We seem to be having a bit of a delay on the RTMP feed. Yeah, there was this thing that I used to do on my with my connection years ago, where when the connection would start to misbehave on certain machines, and I would be getting like very slow internet speed, I would switch off the router for a good like 5 minutes, 5 to 10 minutes. I think, yeah, I think it was around 5 to 10 minutes. I think it was 10 minutes. I don't remember how much exactly I would give, and there was a specific reasoning behind it. I never fully understood the reasoning there because I don't fully understand the telecommunication stack at work, but because of uh, because of something within the working of the telecommunication stack, either on my end or on my ISP's end, because of something, some sort of mechanism within, not some sort of mechanism, because of the way that things are set up, either on my end or on my ISP's end, the way that the communication is handled between my end and the ISP's end. Sometimes there would be some sort of clog, traffic some sort of traffic jam, let's say, for lack of a better term, because I can't really explain it very well. There would be some sort of traffic jam, which would only get cleared out um, if I switch off the router and keep it off for long enough that the connection quote unquote resets. And then it clears up all of whatever that jam was. And whenever I would switch the router back on, everything would be back to normal. For a while, I haven't had to do that. I would usually have to do that on machines that were using Wi-Fi, but then I slowly started moving everything over to wired connections because the wired connections are much faster. So I haven't had to do that for a long time. I do still have to reboot my router. I have to restart the router at least once a day. Otherwise, again, there's that, you know, weird issue. Uh, I say weird issue as if it describes anything. Uh, Basically, it would just be speed issues. There would be like buffering when I would be watching live streams or anything like that. It would be very clear that yeah, the internet speed is quite low right now. So I have to restart the router, and then everything will be fine. Anyways, that was a bit of a tangent. Back to what I was saying. I realized that, so I was planning on working on the content pipeline, right? This was supposed to be the content pipeline. I'd made a bunch of these scripts, and some of them are still work in progress. I even made, scratch notes. Give me a second here. In order to show it properly, I need to work in a lag-free environment. But yeah, um, I'd even made scratch notes. I'd even made like a README file. Um, there was a bunch of stuff that I'd set up, and this is Content Pipeline V1. This is the first version, and there is actually quite a bit that I can do with this. That's why I set this up. I slowly like expanded the functionality of it. Granted, it's kind of on me that the project did suffer from feature creep. This was supposed to be a fairly simple project that I was supposed to get done pretty quickly, but then I started introducing more and more things into it, and things kind of just got complicated. Like, for example, I decided to add in the optional, uploading the YouTube video to the channel kind of thing. I decided to add that in, but then I never managed to set up that script. I wanted to create a script to analyze the entire transcript of the VOD, and that would require a bunch of NLP focused tasks for me to perform. And I never managed to set that up either. I was supposed to learn how to how to use the polars library, but then I kind of stopped that at some point as well. I didn't stop, but like I just got busy doing other stuff. I need to go back to polars because, dude, I don't want to go back to pandas. I'm definitely using polars. Like from here on out, I would very much prefer to use polars because I've used polars long enough that I've gotten a taste of what the API is like, and the API is it's very much ergonomic compared to pandas. So I would prefer to, stick with polars. The thing is, I just got busy doing other stuff, like ESP32 stuff, for example. But there was also a bunch of other things that I got busy with, and because I got busy with all of that stuff, so even polars kind of got pushed to the side. The point is, the content pipeline version 1 is nowhere near being complete. It can be used. There are certain portions of it because I built it in a modular way. So I was building like, bit by bit. That's why there's these multiple scripts that you can see here. Um, However, it is nowhere near close to being done. So I didn't want to waste my hold on. Um, okay, yeah, I didn't want to waste um what am I trying to say here? I didn't want to delay the creation of the content for, very long, because if I just keep waiting until I fully finish the content pipeline, I don't even know if it's going to be ready in the next 2 months or 3 months, if I'm being fully honest here, because my tendency to, get distracted and start doing other stuff, it's pretty high. So there's a decent chance that I might get distracted. So instead, I had this idea. I know that Gemini is able to analyze, first of all, no, I know that Gemini is able to read. That's the important part. Gemini is able to read the transcript of a YouTube video that I feed into it. If the video has been uploaded long enough that the YouTube system has managed to generate the transcript for it, then, if I plug the YouTube video, any YouTube video, into Gemini, Gemini is going to be able to read and analyze the transcript. Okay, great. Then, what I want to do is get Gemini to analyze the transcript of a VOD and generate, what do you call it? Analyze the transcript of a VOD and generate timestamps. Basically, what I told Gemini to do, let me come back here and go into empty directory. Actually, there's something I need to check real quick before I do that, because I do not remember what I put into this, into some of these files. So I'm just gonna open up some of these files and check and make sure everything that's in here is, everything that I'm comfortable with showing. Okay, there's this, and then there's O3. O3 has this as well. I can't remember which specific one it was that I agreed upon. It definitely wasn't O1. It wasn't O1, but in O1 you can see the prompt. So what I'm gonna do is, okay, you know what? I can close this, and then I can come here and cd into empty directory and open up NeoVim in this directory. Give me a second. Okay, right. So we'll do this and that and that, and we should be good, hopefully. Right. So this is the prompt that I set up with Gemini. I said, Okay, so this is the prompt that I set up with Gemini. I said, uh, wait, I need to scroll up. Yeah. Okay, now that you have analyzed the script, oh, I should change that to transcript. I just realized that. Anyways, I've saved the prompt. I said, okay, now that you've analyzed the transcript, I want you to find clippable moments. The criteria is the following. They have to be either informative, educational, interesting, or funny. That's the first criteria. And the second is they can be anywhere between 30 seconds and 10 minutes in length. Because I tried telling Gemini they can be initially what the prompt was initially the this specific criteria was they can be 30 seconds, 3 minutes, 5 minutes, and 10 minutes or 10 minutes in length. And what I noticed was that because of the way that I worded that, it seemed like, and I realized this much later, that it seemed like I was saying that it needs to be strictly these time limits. So the clip needs to fit, the clip needs to be 30 seconds or 3 minutes or 5 minutes or 10 minutes. And I noticed that Gemini was kind of sticking with those times, which is actually great. That's amazing. Like, uh, given the instructions that I was giving Gemini, it was following, it was following the prompt. It was following the instructions, which is great. That's awesome. Um, So I changed it, and then it started giving me anywhere between 30 seconds and 10 minutes in length. And then further on, I said, feel free to generate anywhere up to 20 clips. It's okay if the clips overlap each other. I felt like this was important to mention because I didn't want Gemini to try to avoid situations where, some clips might be overlapping each other, because there might be certain clips that are um, maybe there might be a 5 minute clip, okay, and within that 5 minute clip there might be a 30-second clip, but then Gemini is going to choose between one of those two and only give me one. I want both of them because they can both be they can both be posted as separate um as separate clips. All right. Further on, I said, for each clippable moment, generate the following output: start and end timestamps, SEO focused title, basically just a search engine optimized title, something that's gonna, help push the video in the algorithm. And then also SEO focused or attention grabbing caption. This is specifically for YouTube, but possibly also for Twitter. If I because I do plan on posting these clips on Twitter as well. I don't see why not. If the clips are being generated anyways, I might as well post it on Twitter as well. Actually, no, I take that back. It's not only for Twitter. No, I just realized this. The caption is not only for, sorry, the caption is not only for YouTube and Twitter. I plan on posting these clips on TikTok, Instagram, Threads, YouTube, and Twitter. So the caption can be used in all of those places. In fact, the caption will help in all of those places. Additionally, on Instagram, I'll have to, pick the hashtags myself. I think a couple of months back, Instagram changed their hashtag limit where you can only do 5 hashtags. Otherwise, people would just spam hashtags for the sake of, SEO. And I mean, I don't even blame them. Instagram, I don't, holy shit, dude. Instagram's search algorithm is ass. It is, it is shit. Instagram's search algorithm is horrible. Threads search algorithm is much, much better. Instagram's algorithm has always been horrible for searching stuff. It's great if you want to, search a specific a specific username. It's great if you want to search for a specific hashtag. But even within that hashtag, if you're trying to find content, sometimes you'll have trouble finding content within that as well. But yeah, Instagram's search algorithm is just horrible. Why was I ranting about their search algorithm? Oh yeah, I was talking about like how people would spam hashtags. I'm people. I would also spam hashtags. Uh, for a while there was this thing that people would do, which again I'm people, where they would post the caption for the video, and then they would put 5 dots beneath that. 5 dots as in one dot on one line. So that kind of creates a space. Um, and after those 5 dots, they would just spam a whole bunch of hashtags. And that was supposed to, help the algorithm push this person's video and make this person's video slash post be more discoverable and stuff like that. But these days you're relying more on, but you're relying less on hashtags and more on the algorithm to push you. It does help when there are very specific like groups that you can post in, or grouped tags that you can post in. Like if for example, on Twitter, they have this, they have like, I forgot what they're called, groups or communities or something like that. When you are creating a post, you can add a topic or a group or slash community that you want this. So if it's a community, then when you add that post, when you add the community's name to your post, then your post is going to be posted in that community, and people who have joined that community they'll also be able to see the post. If it's just a topic, then people who are searching for that topic, they will be shown this post. And also additionally, people who generally interact with those kinds of topics and with those kinds of communities, they will also be shown your post by the algorithm. So it helps in that manner. But for the most part, like people are heavily relying on the algorithm to whatever website it is. People are relying on the algorithm to push the video, or a photo or whatever it is. People are relying on the algorithm to push it. And a lot of times it just comes down to having the right kind of metadata, which these days doesn't often involve tags or hashtags. Back in the day, it definitely involved hashtags. Um, to a certain extent, it still involves hashtags, not very, very heavily. But yeah, yeah. So, anyways, the caption is going to be necessary. The title is going to be necessary, at least on um, platforms like YouTube, because if I'm posting a video on there, I have to give a title to the video. I don't know if I'm required to give a title to um, a Threads video, an Instagram video, a TikTok video, or even a Twitter video. I don't remember if I have to give a title, but the caption is necessary. So I asked Gemini to additionally also generate this. I'm just hoping that Gemini is able to analyze the entire transcript, even the center of it, because I remember Gemini itself telling me in the past that um, LLMs, they tend to have this issue when they have to analyze long form content. Um, the issue is that they don't analyze it very well. Dude, oh, you know what? I just realized I wonder if I can use Notebook LM for this instead of Gemini. I wonder if using Notebook LM would benefit me a little more. I'll have to test that out, because Notebook LM has this. Notebook LM is meant for this kind of purpose, like dealing with, text content, and generating like stuff like summaries and explaining things, and various things to do with the content itself. So if it's massive content, then I'm pretty sure Notebook LM is able to handle it very well. And Notebook LM is now there's integration with Gemini, so I I should look into that as well. Either way, this is the result that I got from. Wait, did I? Yeah, I gave one final instruction saying format the entire output as JSON in the following format, and then I wrote down this this little JSON template. for Gemini to follow. And to my surprise, it actually followed this. Usually in the past, I would have this issue where Gemini would add in, some extra fluff text saying, "Sure, here's your answer," and then so and so, so and so, and that made it not so great for um, that made it not so great for automated tasks. Like I couldn't just plug Gemini into a system and be like, okay, accept input from this and give output to that, because I wouldn't be sure what kind of output Gemini was going to give. And if Gemini didn't give proper structured output, it would break whatever the system is down the line. But yeah, in this case, I was able to get it. And all I had to do was copy it. So this is what the output looks like. Scratch O2 has one iteration. Scratch O3 has the final iteration. And I'm pretty happy with the way that this turned out. You'll notice that it mentions Dan keys. Well, the transcription system doesn't really know dem keys, so it tried to guess its best, and I guess that's what it came up with, Dan keys. And so in a bunch of the captions, anytime it wants to mention dem keys as a third person, it mentions Dan. So it thinks I'm first name Dan, last name Keys, and so it says Dan does so and so thing. But yeah, this is the output, and this is exactly what I was expecting. I'm very happy with this output. Now I just need to make sure that whatever has been gathered, whatever has been analyzed by Gemini and labeled as entertaining, or oh, you know what I could do? Oh shit. I could also, I mean, I don't know if this would negatively impact the I don't know if this would negatively impact the final answer somehow. I just realized that I could have added additional fields into this output to say to give it like a score. So okay, I gave a couple of labels here, right? I said informative, educational, interesting, or funny. These are our labels so far. I could add the score here. I don't know if if that's gonna unnecessarily complicate things at this point. However, okay, this is the output that I've gotten so far. These are the clips that I need to now um, create an automated process to. Oh, hold on, let's do wrap. Yeah, so these are the clips that I need to now create an automated process to extract using FFmpeg and a bit of Python. So that's going to be the next step. And this was significantly faster to do. And I'm super happy about that. It is a little more manual though. I'll put that out there. It's definitely a little more manual. It's not as tedious though. There's also that. Um, because I just have to upload the video and then give it like a day or two. Within a day or two, I believe the transcript gets generated. Once the transcript is generated, I can feed the video into Gemini and ask it to generate, this JSON output. And then I can save this JSON output to a file and just let it be there. In fact, I could feed this JSON output into a file and then immediately plug this output. I mean, I'll save it to a file, and then I'll plug that file into my Python script immediately to start the um, to start the sorry, got distracted. I can feed this JSON output directly into my Python script to start the extraction process. Yeah, yeah. And this will be much, much faster than what I was planning on doing before. However, the quality is still going to vary. I don't know how good or bad the quality is going to be, but this is going to be our first iteration now, technically. Well, this I'm so what I'm calling this is content pipeline version 0.5. And then the actual content pipeline, the one which I'm building from scratch, that is going to be version 1. So, that's the plan so far. And the way that I've set this up, I do need to spend some time writing that Python script. I think I'll do that today after today's stream. I'll write down I'll write the Python script to set up the extraction process. I want the clips to be as glitch free as possible, so I'm gonna go with the decode and encode um, workflow in FFmpeg, because in FFmpeg, when you are extracting a clip, you have two ways of there's probably more ways of doing it as well, but two ways that Gemini has told me are, one is the copy method, which is where you're quite literally just copying the frames. um, that's not entirely glitch free though, because you um, you can end up with a frozen frame or a black screen at the beginning or at the end of your clip, just because of the way that things are being cut and because there's encoding involved. Um, you can have this glitch at the beginning and the end of your clip, and this wouldn't really be a big deal if I was planning on trimming the video. Um, what was I saying? Yeah, this wouldn't really be a big deal if I was planning on trimming the video before uploading it. The thing is, I still can trim the video. Um, I was actually planning on trimming before. So okay, I was planning on trimming off the start and the end of. Wait, I just realized something. Um, the RTMP feed froze. Okay, now it's running. Okay, give me a second. I'm just gonna take a short break. And not a second. Give me a couple of minutes. I'm gonna take a short break, and I'll come back, and then we'll start with the async programming stuff, the embassy stuff. Um, or maybe we'll just continue talking about the content pipeline. I don't know. I'll see. But yeah, give me a couple of minutes, and I'll come back. All right, I am back. Give me a second. Let me just refresh this RTMP feed. And you know what? We're gonna do embassy stuff. What I'm gonna do is I'm gonna increase the size of this browser because we are probably gonna be doing a lot more reading today. I think this is good. Yeah, yeah. I think this is good. Right. So I have to work on the content pipeline version 0.5. The good news is once I have set this up, which this should be, you know, much simpler than, I mean, I'm saying it'll be simpler because there are only a select few things that I have to do right now in this, and there's going to be a whole lot more manual work involved. Um, that's why setting it up is going to be a little more simpler, and it's also not going to be, there's not going to be any batch work going on, there's not going to be batch processing going on. It's going to be very much manual work. The only time there's going to be batch work going on is one, when there's extractions happening. So when we are extracting video segments out of the VOD, that's going to be a separate FFmpeg invocation each time. And fortunately, FFmpeg does have a flag allowing you to specify the number of threads to use. So what I can do is I can set it up to run the extraction on any of my, uh, not any of my, on one of my machines over here, maybe on the same machine where I'm generating, where I start the, uh, how do I even say this? Maybe on the same machine where I have my Tmux session hosted, I can start the extraction process there. Um, the thing is, okay, so there's going to be two steps here. One is that the clip has to be extracted, but also I would like to extract from that segment. I would like to extract the I would like to add jump cuts in there to remove essentially dead air. And the way to do that, the best way to do that is through the FF. So FFmpeg has this very sophisticated filter system. And within it, you can do a bunch of things by like how do I even say it? There's a certain vocabulary that you have to specify. There's a way to set up these various filters, and you can plug the output of one filter into the input of another, and maybe you can also split outputs, and you can describe all sorts of stuff with very specific syntax. Um, I don't know any of it. I'm not going to learn any of it. I'm just going to get Gemini to generate that specific stuff for me. And I know Gemini can do it because Gemini has generated this for me before. I asked Gemini, I said that I have this video clip and I would like to remove the quiet segments from it. And then Gemini was like, yeah, this is what you would be using. Here's how you use this filter system, how you specify the entire filter string, and yeah, yeah. So what I could do is, in each invocation, I'm going to be specifying a start and end timestamp. So like if there's 20 clips, for example, it's going to be 20 invocations. Each time it's going to be, I'm calling ffmpeg, I'm specifying a start time, then an end time. Additionally, whatever, extra flags I want to specify, I'm going to go the re-encoding route instead of going just the copy route, because the copy route is going to, as in using the copy flag, it's going to leave in the beginning and ending of the clips, there could be frozen frames or black screens or something like that. So instead of that, uh, I'm just going to get FFmpeg to re-encode. Well, first of all, decode and then extract the thing and then re-encode that. And hopefully it shouldn't take too long. Hopefully it should be fast enough. But even if it does take some time, I really don't mind that. I'm okay with that. I can optimize it, you know, later down the road. Um, but for now, I think if I'm able to let this script run and do its thing, and in the end, um, it produces clips that I can then post on social media, then my work becomes significantly easier because these are then clips that I don't need to, make by myself. Um, Something that I would definitely need to work on is maybe specifying a filter of some sort, video filter specifically, because like okay, in when you're making Twitch clips, Twitch allows you to create both a landscape and a portrait version. And in the portrait version, they allow you to specify regions of your landscape video that will be captured to build the portrait version. So this is amazing. This is great because you can like do your quote unquote editing within that clip editor itself, and your clip is then ready and you can upload it to social media. It's great. It's amazing. Depending on what your setup is like, it works out great. If you have a whole bunch of things spread out here and there, then like me, for example, then maybe not so great. But that's kind of why I want to try setting up my own thing where I can specify regions um, to to place within the video. But I feel like at that point it becomes very, very complicated. I feel like it's going to be more well, okay, it doesn't have to be complicated though, because the regions don't have to move. So I can specify the region and just have it uh I can specify the region and just have it, use that region. I'll specify the region in some way, like maybe in terms of rectangle coordinates or something like that. I'll have to see how to go about doing that in the first, but that's later on. I can still do that. I should be able to create something to do that. But that's down the line. Now, for the time being, just getting landscape clips. Um, that should be great, and at least it'll get me started in terms of uploading clips to social media. Besides, I mean, having landscape clips is not really that bad, especially considering that if it's longer videos, like minutes long videos, and I'm posting it um, to Twitter or to YouTube, um, a lot of people will be watching those in landscape, even if it's like even if the video is landscape, or even if they're watching it on their phones, they can watch the thing in landscape. If it's a longer video, then I don't think it's a problem for it to be in landscape. So for the time being, I think I can be a little bit lazy with this, just for the sake of getting the content pipeline up and running. Okay, that being said, I've yapped enough about the content pipeline for now. Let's get into this. So yesterday, I read this page. I don't think I need to read this again. I've read this already. We can jump into it. I don't know how much of Embassy this really teaches. So instead, I'll open up the Embassy docs, I guess this is. Uh, I didn't read this part though. Okay, async program. Oh, this is telling us what async programming is. Yeah, okay. Basically, it allows us to do multiple tasks concurrently, not necessarily in parallel, but concurrently. And through the use of like context switching and stuff like that, Though I don't know how it works in I don't know how it works in on the Rust side, and more specifically, the embedded side. So I can't say for sure that that's the case, but they have their way of setting up. They have their way of allowing you to set up and execute tasks that would continue running while your other tasks can also run. So you can set up a task. You can set up task O1, for example, start the task, and if it hits a point where it has to wait for something, or if it hits a point where there's some sort of limitation from the hardware and it's taking time for the response to come or for the calculation to be done or whatever, you can jump out of that function and go back to the main function and continue from there. So that will then allow you to spawn another task and start that work as well. And maybe that's targeting some other hardware, hopefully. And then both of these tasks will be running and doing their thing. They're not necessarily running, I mean, depends whether it's a CPU bound or IO bound task. But the point is, whenever the task is complete, let's say task O1, which you were waiting for it to finish earlier. Let's say task O1 is complete. You can then jump to that task, and finish out from that function, and then go back to the main function. That's like the Okay, to be fair, what I just described is how task-based asynchronous programming worked on the C# side. It's sort of similar on the Rust side, but I don't remember exactly how Tokyo does it, and I don't actually know how Embassy does it. So I can't say that this is exactly how it's going to be. But this is kind of the gist of task-based programming, async programming. It's that you are able to run multiple things asynchronously, often within the same thread itself, though with Rust, if you're using Tokyo, then you do have the multi-threading option. But yeah, yeah. Give me a second. I just realized that I forgot to open up my chat on my phone. So I'm just going to do that. Oh, wait. I got to follow. Hold on. Um, yeah, thank you for the follow. T Goat. Welcome to the stream. Hello, hello. How's it going? Um, we are currently about to learn about async programming for async embedded programming in Rust. Also, there seems to be something else that I forgot here. So give me a second while I set that up. Okay, all right. Uh, Hold on. Yeah, okay, back to this. In fact, maybe I can freeze the matrix rain because we are mostly reading you know the stuff in the browser. Um, but yeah, we read this part yesterday. Embassy. We read the HAL portion yesterday. I think we read the batteries included thing as well. It says Embassy comes with many built-in features that many embedded that make embedded development easier. For example, it includes the Embassy Time for handling timers and delays, Embassy Net for networking support, and Embassy USB for building USB device functionality, and much more. ESP-RTOS. The ESP-HAL ecosystem includes a crate named ESP-RTOS, which provides integration between ESP-HAL and the Embassy asynchronous framework. And RTOS, a real-time operating system implementation for HAL, for ESP-HAL, this crate provides the runtime necessary to run async code on top of ESP-HAL and implements the necessary capabilities, threads, queues, etc. required by ESP radio. I didn't know threads were a thing on like the ESP32 side. I know that we have dual core CPUs on some of them, but I wasn't entirely sure that you can tell it to, do tell it to use multiple cores. Actually, I think the second core is what gets used for the radio functionality. I think so. I don't remember. Anyways, so now excuse the light mode. Unfortunately, I can't do anything about it. Now I guess we get into this. However, before this, we could try going to the next page and let's see what it says here. Is it directly like jumping into the Blinky example? Because this is the next thing we're going to need to explore, um, which is async programming. We can't really move forward without this unless we can't really move forward. Let's just say that we can't really move forward, or I don't want to move forward with, ESP32 programming until I learn async programming, because this is going to significantly reduce the headache of, delays between various things. And I feel like the LED blinky example thing that we had, even the LED PWM, fading stuff. These are perfect examples of situations where um, we might need async programming to a certain extent. Though I am curious how we would go about. Um, oh yeah, wait. I just realized this. I was about to say that. Okay, I am curious how we would go about starting and maintaining the PWM operation for like two separate LEDs. But we can do that. Because I just remembered that the fading is handled within the hardware. It's not being done like in dedicated hardware. I mean, it's not being done by the CPU. So when we call start with fade, then it essentially sends a message, or it starts. How do I say this? It sets whatever variables it has to set within the fading hardware, and then the fade starts. So the fade is just going to keep going on, and it's going to keep repeating. Actually, wait, back up. It's not going to repeat. Okay, okay, that's one thing. Yeah, it's not going to repeat. We need to look into how we could get it to repeat, because um, starting it is easy. We can start it outside of the ESP32 loop. ESP32 loop. No, we can start it outside of our loop as well. It doesn't have to be inside the loop. But that'll start it once. It'll start the fade, and the fade will just continue. So, like for example, okay, you guys won't be able to see this, but I'll push this here. I'm redoing the example. Oh, actually, you can't even see the video feed. I'll have to start the stream and come and do this and refresh the feed here. Let's take a look. Okay, this is running. So if I reset now, you can see the fade starts all over again with the red LED, and it's gradual. It's over 10 seconds. So it goes from 0 duty percentage to 100 duty percentage over 10 seconds. And in the meantime, uh, so this fade started outside of the loop, right? And then in the loop, I have a delayed LED toggle mechanism set up. Okay, all right. Let's get back to this. So blinking an LED with ESP32 Embassy on ESP32 in Rust. Let's set up the Blinky project, but with Embassy support. Oh, I might need to generate a brand new project. I think that's for the best. I think that's for the best. Let's generate a brand new project here. Um, uh, okay. So we are gonna come here, learning ESP32 Rust. Okay, ESP proj. Actually, no. I should wait. We can close this. Okay, do I have access to ESP32? Learning ESP Rust. Okay. Um, learning ESP Rust. We're gonna do ESP generate. I think that's it, right? And then what is the name of the project? The ESP proj of '06. Okay, so we are doing this for ESP32, ESP proj '06. Okay, we want the unstable features. We want the Embassy framework support. We want for flashing, use the log crate to print messages. I think I want this, right? Yeah, because I had oh, you know what? I think I should enable both of these things as well. Use ESP backtrace as panic handler. Use DFMT to print messages. Oh, that's interesting. Wait, back up, back up. So you can only have either or. You can't have both of them. That's interesting. Though, I mean, they're both for printing messages, so I guess that's why. I don't know yet which one I want, especially for like printing. Um, which one should I be going for? Also, like for the panic handler, I'm assuming I need that because I'm expecting it to send back panic messages, like whenever there's like an error returned. So if I do unwrap and there's an error returned, then it should show the panic messages. Okay. Options, add support for so and so, so and so. I don't need that. I do need the NeoVim integration. And then Rust toolchain. Yeah, we can do that. Um, you know what? I can't decide which one I should go for. Wait. I'm using ESP generate an ESP32 no STD Rust project. Um, should I use log crate or dfmt to print messages? In the world of embedded Rust, especially when working with no STD on an ESP32, the choice between log and dfmt comes down to a trade-off between standardization and efficiency. Here's a breakdown to help you choose the right path for your ESP generate project. The log crate is the standard logging facade for the, that's an interesting way to put it, standard logging facade. Unless facade is meant to be something else here, and I'm supposed to be pronouncing it in a different way. Like, I don't know. For the Rust ecosystem, in the ESP32 context, it is usually paired with ESP print line. How it works, it formats strings directly on the ESP32 chip and sends the human readable text over the serial port. Pros, simplicity. You don't need special tooling on your host computer. Any serial monitor like Screen, Minicom, or ESP Flash will show the output immediately. Compatibility, most third-party crates use log, so you'll see their output integrated with yours. Cons, resource intensive. Formatting strings on chip consumes CPU cycles and increases binary size, flash and RAM, and it is slow. Sending long text strings over UART can create bottlenecks in your timing sensitive code. That's something good to keep in mind. DFMT, deferred formatting, is a highly efficient logging framework designed especially for resource-constrained devices. Okay, how it works, it does not send strings, it sends tiny compressed binary identifiers. Your computer then uses the ELF file on your project, your project, to decode these bits back into human readable text. Pros, blazingly fast, minimal impact on the timing of your application. It has a tiny footprint, significantly reduces the amount of flash and RAM used for logging strings, and it has advanced features. It supports timestamps and structured logging out of the box. Cons, tooling required. It requires specific runners like okay. It requires specific runners like probe RS to decode the messages. ESP32 support, while improving, it is traditionally more at home with the ARM Cortex M chips. On ESP32, it often requires transport layers like RTT or a specific UART wrapper. So I need log then. I don't need DFMT. Now, what was the key to save? It was S. Is there anything else I need here? Um, I don't think I need any of these. How do I enable these though? Dough. Though. How do I enable these though? Like that. Okay. Enable Wi-Fi via so-and-so, enable BLE via so-and-so, enable BLE via so-and-so. Okay, Embassy has already been, okay, what if I didn't do this? Then that option wouldn't be available. Okay, all right, great. Okay, all right. I think we are good to go now. So our project has been created. We're going to go into ESP proj. Oh, back up. If we go next, that's rustproj05. Okay, okay. We can probably close the other one. I mean, at this point, I might as well just close the other one and open up this one brand new. Yeah, I feel like that's the better option here. So, okay. Um, there. Great. We can close this. We can close this. And I guess we can open up NeoVim here. All right. Here I guess we. Oh yeah, we have the bin thing set up here already. So if you actually I can't show it now because I had to change that. Wait. So previously, because we had built this entire project from scratch, shout out to, the Impel Rust. I just realized something. I feel so stupid. You guys did not see anything. You did not see any of the NeoVim stuff that I was doing, any of the ESP32 project creation thing that I was doing, because I had the browser window hiding everything. Great. Awesome. Anyways, we created a project for the sake of showing you what the creation looks like. Um, I don't know if I'll be able to skip out of this. So let me do it here. Um, we'll come in here. We'll do ESP generate, select the chip, test O1. This is what it looks like. This is our, oh, yeah. This is what I guess I should do it again because there was a delay on the okay, test O1. This is what the thing looks like. Um, so you can then select, you can enable or disable certain features. I enabled unstable features. I enabled, Embassy framework support. Um, Down here, I enabled, um, that's interesting. Oh God, wait, back up. It's showing me this. No, no, no. It is showing me this. I selected the wrong chip. Does it show which chip I selected? I don't know if it shows the chip that I selected. I selected the wrong chip. Sorry, I was dealing with no, I didn't select the wrong chip. It's the right chip. Yeah, that's surprising that now that I'm doing it in this way, it's yeah, previously it was showing log, but now it's showing panic RTT. So I'm not sure what's going on there. Oh, oh, these are two different things. That's why. Okay, one is for Probe RS and one is for ESP Flash. I'm supposed to be looking at this. So anyways, I selected this and I selected this. Um, the ESP backtrace panic handler thing, I'm mainly hoping that it'll generate the boilerplate code. Actually, I can see if it generated the boilerplate code. Hold on. Let's open this up. Okay, so we have a bunch of the code here. Um, we also have the boilerplate code for our async programming stuff. We have embassy related stuff that's been, included in the code. There's our app descriptor thing. I keep again and again, I keep forgetting like all the specific things that the app descriptor does. Um, because there's like a very specific set of things that the app descriptor does, and I don't work with this nearly enough to actually remember what it does, but I just know that it's necessary. Where's the panic handler code? Okay, I don't think it has been created here. In another project, I did see it created, but it doesn't seem to be there here. Okay. Um, in the meantime, while this is doing its thing, I guess I can turn the browser back on and we can continue reading. Okay. So this time we selected Add Embassy Framework Support. This requires the unstable feature. We'll first click Enable Unstable HAL Features and then proceed to select Embassy Support. Finally, we'll press S to save the generated project with Embassy Support. Okay, key points. If you notice, the main function is now marked as async along with other changes in the code. What? If you notice, the main function is now marked async. Okay, yeah. However, the core logic for blinking the LED remains the same. This is something that I noticed in Tokyo as well, and this is when I truly understood what macros are doing, because this thing is a macro. If you look here, not well, yeah, yeah, it's essentially a macro. So what this does is, based on the async method that you have created here, it generates some extra boilerplate code to then use your code as well. And I remember this being a thing with Tokyo as well, because it starts up its own runtime, and then it runs your main function as an async function. But you don't need to do that. You don't need to write that code manually. You can just add the macro on there, and you're good to go. So it does the code generation for you. Okay, key points. If you notice so and so, so and so. Okay, the key addition is this part. Time group, new, so and so. Okay, time G, peripherals.timeg. What is time G? Actually, we can read it here once IntelliSense starts working, because it is currently doing its building thing, I think. Yeah, it's still doing its building thing. I don't want to interrupt it. It has a bunch of building to do. I should have run cargo build before I opened up this project. Honestly, I should have done that. Okay, I think no, we are not. We are not good. I was about to say, oh, I think we're good to go, but no, we still have a little more to go. Now I think we're now I think we're good. Okay, all right. Oh, it automatically added this. I didn't know that it automatically adds the thing. Okay, let's read that. Um, so this API is marked as unstable. Okay, okay. All right, this comes with no stability guarantees. All right. Okay. All right. Let's continue. I also just realized that cannot see you cannot see NeoVim again because I placed the browser right there. So what I'm going to do is move this now because we've had enough interruptions or enough obstructions. And this keeps happening. So let me just transition back and make the screen small. Let me also refresh this feed. Okay. All right. Now, back here, this sets up a timer that Embassy needs to handle. Wait, yeah. This sets up a timer that Embassy needs to handle async tasks like delays. We create a timer group. Use We create a timer group using hardware timer timg. All right. Then pass one of its timers to ESP32 start to let Embassy use it for timer-based operations. Okay, so first I need to look into timer groups in um okay, hold up. I'm learning ESP32, no STD Rust, and I just came across no, and I am currently learning about async programming with Embassy. Explain uh, explain timer groups. Okay, diving into so and so, so and so, so and so. Great, awesome. In the ESP32 architecture, timer groups are the hardware heart of timekeeping and watchdog safety. Here's how they work and how Embassy utilizes them. What are timer groups? Most ESP32 chips feature two hardware timer groups, timer group 0, T0, and timer group 1, oh, sorry, TG0 and TG1. Each group typically contains two general purpose timers, which are 64-bit up-down counters with prescalers, and one watchdog timer, which is a fail-safe timer that resets the system if the software hangs. Okay, the prescaler. Oh, what just happened? Okay, the prescaler. Timers don't just count every clock cycle, which would be way too fast. They use a prescaler, a 16-bit divider that slows the clock signal down to a manageable frequency. If your clock is 80 megahertz, and this is where our previous research about, clock signals and clock dividers and how all of this clock-related functionality is working, this is where it's going to be super helpful to help me understand you know, how things are working here. I'm so glad that I took how much ever long I took to understand PWM and clock signals. Otherwise, I would be lost like completely over here. Sorry, zoned out. Um, Sorry, I was just thinking about something. Okay, so the role of the watchdog in a no STD Rust environment, the watchdog is active by default at boot. If you don't feed it, quote unquote, feed, that is reset its counter or explicitly disable this, your ESP32 will boot loop indefinitely. When you initialize your peripherals in Rust, you often have to handle these immediately. Okay. Why Embassy needs them? Embassy is an async executor or executor. Let's say executor. Executor? I mean, there's executive. You can also say executive, but that's not a very, I mean, you just changed the inflection there, right? But anyways, yeah, okay. Embassy is an async executor. For async to work, wait, was I going with executor or executor? Let's say executor, whatever. Is an async executor. For async to work, example calling dot await on a sleep function, the executor, I keep going to executor. I'm just gonna say executor, whatever. The executor needs a way to know when time has passed with the executor needs to know when time has passed without spinning the CPU and wasting power. Okay, okay. That's interesting. So it's able to do this without, um, let's say, summoning the CPU. Okay, the alarm provider. Embassy requires a timer divider to act as its timekeeper. Sorry, timer driver to act as its timekeeper. On the ESP32, one of the timers from a timer group is usually dedicated to the embassy executor. Um, Queuing. When you call timer.after.await, Embassy calculates the wake up timestamp. Okay. Interrupts. It sets the hardware timer to trigger an interrupt at that exact moment, and then waking. When the hardware interrupt fires, the ESP32 jumps to an interrupt service routine, which tells the Embassy executor wake up to wake up your specific task. All right. Key differences in no STD. When you use STD, the operating system, FreeRTOS, manages these timers. In no STD plus Embassy, you have to do manual allocation, bit level control. You have bit level control, and it's more efficient. All right. Okay. All right. That answers the question. Okay. You know what? Wait, did they explain the remainder of the code here? So it's our standard code. The panic code, I'm actually not seeing the panic code here. That's the interesting thing. I'm not seeing any panic related code created here. So I'm surprised. I'm surprised by that because I was expecting it to be there. Let's open up this. Okay, we have ESP HAL, bootloader, RTOS, Embassy Executor, Embassy Time, ESP Backtrace. Oh, maybe a panic handler gets created when I don't have ESP backtrace panic handler selected. Yeah, yeah. Maybe that's the case. Oh, you know what? I could test something out here. I could, what did I just do? I could set up no, this is within a async runtime. Okay, there's a bunch of things that I want to experiment with here. However, we have run out of time for today's stream. Okay, this is on me. I started the stream a little bit late. I'll try to start the stream earlier tomorrow, and hopefully we can get a little more time to do our ESP32 studies. Now, give me a second. Okay, I think we'll just go to this person. I don't know what they're doing, but the raid is going through. I usually don't raid like people who have like a lot more viewers. I'm a little, nervous about raiding bigger channels. But yeah, this person was recommended in the sidebar by Twitch. So let's go to them. But yeah, dude, we made some good progress today. Uh, After this, I have to continue working on the content pipeline. I definitely want to get something going, hopefully in the next day or two. I want to get something set up and actually extract clips. Once I manage to do this, we are gonna have some content to post. And since I'm uploading, my VODs, I'm streaming daily and I'm uploading my VODs. So we should have a fair bit of clips, and hopefully I'll be able to post at least once a day, if not multiple times a day. But yeah, let's see. But that being said, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.